Hello and welcome back to Jamango Academy. In this episode, we're building a checkpoint system that saves player progress as they move through your obby. If a player falls off the course, they'll respawn at the last checkpoint they touched, instead of going all the way back to spawn. But it's ultimately up to you in how mean you want to be, so if you decide to only have a few checkpoints throughout your whole game, you can do that too. In the last video, we wrote some code which checks if the player has fallen off. In this video, we'll be updating this script to have multiple respawn points, so when players do fall off, they'll go back to their last checkpoint. We'll be using this respawn script, which you need to make sure that it's imported correctly through server.ts and client.ts. But once you got this all set up, our first task is placing checkpoint pads into our game. To do this, we'll create a checkpoint trait and attach them to box areas. This trait will hold a single number, being the ID of our checkpoint. The first checkpoint in our game will have an ID of 0, and then 1, 2, and so on. You'll see that we've called this checkpoint trait so that we can keep track of it in our code, and the value that this trait holds in its schema is a single number, that being our checkpoint ID. Going back into our obby real quick, I've set up this small demo for today's episode. You'll see that I have these two box areas along the course, which I want to be my checkpoint areas. So I'll simply click on them with the wrench tool and apply the checkpoint trait that we've just created. Since this checkpoint is first, I'll give it an ID value of 0, and then this next one I'll set to 1. Now that we've set up our checkpoint traits and checkpoint areas in our game, our second task is storing the checkpoint number that the player has reached so far. To keep track of values for each player, we can create a trait for the player, which contains the last checkpoint ID that we have reached and also the respawn coordinates that they'll go to when they fall off. So we can write const player checkpoint trait equals j.defineTrait to create our trait. And then in its schema, we'll have two different numbers. Firstly, we'll enter a spawn vector 3, which represents where we'll spawn back to when falling off our obby. The next variable is player checkpoint ID, and this will simply be a number. But this trait is a bit different because we don't attach it to our players with the wrench tool. Instead, we'll be applying it through our script. To make sure that every player has this trait on them, we'll use j.onPlayerJoin player ID. j.onPlayerJoin runs every time a new player joins our game. It gets the unique ID of that player, so we can differentiate and identify each player. Next, we'll use j.setTrait to attach the player checkpoint trait to our player. The entity that we're setting the trait of is our player, which is represented by the player ID, and the trait that we're setting to the player is our player checkpoint trait. Then we write in some default values for our spawn, which for now is just at the spawn island at 0, 2, 0. And for the checkpoint ID, by default, we'll set it to -1, and this indicates that the player hasn't reached any checkpoints yet when they join the game for the first time. So now that we have all of our traits set up and properly attached, our third and final task is to update our respawn logic. To kick us off, we'll use j.onEntityCollisionStart, which is a Jamango function that detects when two objects collide with one another. In this case, it's when our player walks into our checkpoint box area. We need to tell Jamango what the source object is, so we're looking for objects with the player checkpoint trait attached to it, which is our players. And then the target of that collision is our objects with the checkpoint trait, and that'll be the checkpoint box areas. Next, we need to get a hold of the IDs of these objects. To do that, we can simply write source ID first and then target ID. And we'll use these IDs to access the player and checkpoint traits. To do that, I'll write const player trait and set it to j.getTrait, which gets the unique properties of a particular trait on an object. We want to access the traits of our source object, which is our player, so here I'll write source ID. And then the trait that we're getting a hold of is our player checkpoint trait. We do something really similar for our checkpoint box area as well, just changing the name to checkpoint trait, getting it from our target object, so using target ID, and the trait that we're getting is checkpoint trait. Now our goal here is to update the spawn coordinates of the player to the position of the checkpoint that we've just collided with. Remember that the checkpoint box area is somewhere in our world, so it must have a set of position coordinates. To find the checkpoint position coordinates, we can use const checkpoint position equals j.getEntityPosition. The entity that we want to find the position of is obviously our checkpoint box area, so we'll enter the target ID here, and we'll close it off with a bracket and semicolon. Now we're updating the value of our player trait's spawn variable with this position. We can write player trait.spawn, which is relating to this variable in player checkpoint trait, and make it equal to checkpoint position. So if this checkpoint is, for example, at 50 to 0, our spawn position will update from 0 to 0 to 50 to 0. At this point, we'll also update the other variable stored in our player checkpoint trait, which is the player checkpoint number that they've reached so far. This is really easy. We just write player trait.checkpoint so that we can access the checkpoint ID variable in our player trait, and then make it equal to the checkpoint trait.checkpoint ID, which is the number that we have up here in checkpoint trait, and this is the number that we also wrote into those box areas earlier when using the wrench tool. And now to finish off this logic, we need to load all of this information back into the player checkpoint trait. So we'll write j.setTrait. We're setting the trait of our player, so that is source ID. The trait that we're updating is their player checkpoint trait, and what we're updating it with is the player trait that we've been modifying in this code block. Okay, so let's take a second to chill and recap, because that really was a lot of coding. When our player collides with the checkpoint, we access both the player checkpoint trait of the player and the checkpoint trait of the checkpoint box area. We then update our player's spawn position with the position of that checkpoint box area, and we also update our player's checkpoint ID with the ID of the checkpoint that we just passed. We then save all of these changes by loading it back into our player checkpoint trait. To work this logic into our existing game though, all that we need to do is go down to our on-game tick function from last video, which is constantly checking the position of players and respawns them if they've fallen off our obby. But instead of respawning players at the world spawn when they fall off, we want to respawn them back to where their spawn coordinates are, which is stored in player checkpoint trait. So first we get access to this trait using const player trait equals j.getTrait. And the entity that we're getting the trait from is our player ID, and the trait that we're getting is player checkpoint trait. And then instead of setting their position to 0 to 0 when they fall off, we can instead set it to the spawn coordinates of the player trait. So that's player trait.spawn. The final piece of the puzzle is to make sure that players can't go backwards in the obby because we don't want them losing progress. This is where we use the checkpoint ID variable in the player checkpoint trait. Because an easy way to detect whether we're moving forward or backwards in our obby is to compare the player's current checkpoint trait against the checkpoint that they're colliding with. So in this case, we'll only run this section of the code when a player reaches a checkpoint and if the player's checkpoint ID is less than the ID of the checkpoint that they're colliding with. This way, the player's checkpoint ID can only increase, representing progression through the obby course. To do this, we can simply use an if statement, checking that if the player trait.player checkpoint ID is less than the checkpoint trait.checkpoint ID. And then I'll cut and paste the code that we wrote earlier and put it here inside these brackets. One final thing to add is just a small chat message to the player whenever they reach a checkpoint, because otherwise they might not realize that they've reached it. So we can put a small line of code here by saying j.sendChatMessage, and the message that I'll send is simply checkpoint reached. To make it stand out, I'll put a color code here for bright orange, so that can be FA0, and then to send this message only to the player who just crossed the checkpoint instead of everyone, I'll simply write comma and put source ID within some square brackets. So here we go, that is our advanced checkpoint system completed. Make sure to test this before moving on to next steps of your game. Go to different parts of your obby, try crossing the finish line and see if that activates, then try falling off and seeing if you get spawned back to that checkpoint. Then you can decide how far to space these checkpoints away in your obby, so if you have a large gap between checkpoints, it might be a bit more difficult for your players. And maybe you want to include more checkpoints near the beginning of your obby and then make the end a bit more difficult by not having as many. But either way, congrats on getting through this pretty hefty tutorial video, but now your obby has so many more possibilities for growing out further. I recommend that you build a course with at least 3 checkpoints and share some of the gameplay of it over on our Discord server. You might even get a few people interested in playing your game when it's released. But in the meantime, thanks for watching and I'll see you in the next video.